and I did my PhD from IIT Indore. So we'll start with the new part, new unit of our work and our coursework, that is Advanced Systems Engineering. I hope you were liking my lectures and all the coursework, and we'll have good assignment as well, project work, that is, so that we could have a real time learning. So in this part basically we'll see some advanced topics in systems engineering, like some systems of systems, like systems of systems engineering. So these type of some advanced topic would actually help us to do some understanding growth for the fundamental systems engineering, that actually makes us more capable for doing better systems analysis, better systems dealing that requirement, what are the requirement, what are the interdisciplinary topics that are related to, and basically what we'll study the research part in this, that what, how, and the research takes place. So I'll give explanation with the research that I have done and that was recently been published. And so this systems engineering is basically uh, part dealing with analyzing the system. So I'll tell you that how I did my analysis and how I did systems analysis, and then that will also help you to do system analysis for your own project in future as well. So we'll start with the systems of systems engineering. That is, there are many systems and they are integrated together, and you have to do a complete systems of system engineering. Means it was been recent, means very old topic, but it was being properly defined by that Meyer at in 1988, that we'll see. And we'll see what is systems of systems. First we need to understand what is systems of systems. That would actually give us understanding about what is systems of systems engineering. Once we are able to understand what is systems of systems, then it's simple. Engineering is the thing that we all know that what we are doing. So Meir had defined it like systems of system as there are fundamentally five important things that he told us about. That is operational independency and managerial independency. So what does it means? That there are various domains and various fields, mechanical, electrical, when there are various components, and when there is a system which is built up of a particular component. So one system manager would be there, then second system manager would be there, then third system manager would be there. So all these system manager have to do an operational independency, means they have to work together and work for a similar goal for achieving systems of systems. And that managers have to work for operations and managers have to work in collaboration. So they are been having some independencies. So these type of things are there. Then geographical distribution and emergent behavior. So geographical distribution means various type of systems could be geographically distributed, especially in terms of computer science. So in computer science there are various servers at various locations, various companies are working in collaboration, like Google is working with some other companies, Facebook is working with some other companies. They have the geographically distributed servers at various points. And then the very common one that we are studying and discussing about emergent behavior. So various system, when they interact with each other, so they in self have some emergent property, but when they interact all together, then the additional emergent property would be created. So what are these emergent, additional emergent properties? So these will show up only when we are working with systems of systems engineering. Thereafter, evolutionary development process, like there are various evolutions that happen in our system with time. So with time, system keeps on updating because of changes because of some failure. So you as a system engineer think about what are the changes, what are the evolution that you have to do to maintain it, the system of system, and do the better operation of that system of system. Then what is basic difference between the systems, and what is basically difference between the systems of systems? So we'll see that it actually clears the stakeholders. There are clear stakeholders which are defined in systems. So in a single system you have a clear set of stakeholders, but in case of system, you have multiple levels of stakeholder that have some mixed properties, mixed behavior, mixed understanding, mixed competing property, and mixed interest. So there are various interests could be there, various possibility could be there in the multiple level of stakeholders. In case of systems, then systems would have a clear objective and purpose because it is a single system. So they have clear objective and clear purpose. Then in this systems there is multiple possibilities and some contradictions in their objective and purpose. So it's not that much clear because manager 1 for system 1, manager 2 for system 2, manager 3 for system 3 are having different views and different aspects about their own system. So there may be some possibility of contradiction. Then systems would have clear operation priorities. And what are the priority 1, priority 2, priority 3, what should be focused while operation, what should not be focused while operations. So some escalation of the some issues could be done to resolve some first priority things. So in the systems of system there are multiple and sometimes various and too many types of priorities that actually don't have clear escalation, because system manager 1 would say escalate my uh, priority, system manager 2 would say that escalate my issue first, system manager 3 would say escalate my priorities. So these are having various difference issues. Then what is single level life cycle? So single life cycle would be like a system is one, and you have the design phase, development phase, and what maintenance phase, operation phase, and all these things are only one for a one system. So this is single life cycle for a single system. But there are multiple life cycle because system 1 would have different life cycle for development because it belongs to mechanical. System 2 maybe belongs to electrical, so they have different life cycle. They may fail earlier as compared to mechanical system, and there might be bugs in the system 3, that is software. So software might have bugs, and they have different life cycle as compared to the mechanical and electronic systems. So multiple life cycles are being possible with different elements. Elements means components. So components have different life cycle and they are asynchronous. Thereafter system tends to have some clear views. One system would have a clear view or clear understanding that this is belong to mechanical engineers, this belongs to a software engineers, this belongs to electrical engineers. And there is ability to move resources between element, means mechanical engineer don't have to think about much of different domains, so they can manage their resources easily because it's only mechanical system. But in case of a systems of systems, means a mechanical, electrical, and software system is being connected, so it becomes multiple owners. That mechanical engineers had developed this system, and system 2 was developed by electrical electronic engineers, then system 3 was being developed by software engineers. So they have different decisions and independent views about their own ownership of their own system. Then we'll see what ISO or IEEE IEC had defined about the systems of systems. So basically, systems of system (SOS) was being defined by these community in 2019 as following. I'll read the whole definition so that you'll have, and thereafter we'll discuss about it in detail. The set of systems or system elements. Elements here represent components. So the set of system or system element that interact to provide a unique capability that none of the constituent system can accomplish on its own. Note, system element can be necessarily to facilitate the interaction of the constituent system in the systems of systems. So what does it means? It means that there are some set of systems are there, some set of system components are there. So they interact with each other and they provide some property or some functionality that individual system or system component can't able to provide. So they all work together, means system, set of systems or set of components in different systems works together in constitute systems, and they will provide some and accomplish some uh, property or some behavior that can't be provided by single. Then the system element, means system component, can be necessarily to facilitate the interaction of the constituent system in the systems of systems. So what is a system of system? Makes it makes a constituent system, and it provides what it facilitate the interaction between various system elements. So it's the part of systems of systems. So we'll see the next definition, then the whole both the things will be more clear. Constituent system. So constituent system can be the part of one or more system of systems. So what they said, constituent system is actually some part of systems of systems. Means in case of systems of systems, it's very difficult to make a boundary line. So whatever there is a some functionality that would be provided by constituent system could be said as constituent system. And various constituent systems are making means combined together and making different parts together and working as a systems of systems. So the constituent system was also being defined because there is no fixed boundary of systems of systems. Then each constituent system is a useful system by itself, having its own development, management goals, resources, but interact with the systems of system to provide the unique capability of systems of systems. So each of the constituent systems are useful in itself, means they have some emergent property, they have some behavior. Each individual constituent system have their own behavior and properties. Why? Because they were being developed and managed with a particular goal and resources. So they have some functionality predefined and they are made as a constituent system. Then they interact with each other, means constituent system interacts with each other and interacts with the systems of system to provide some unique capability, means that could have some larger functionality, that could have larger emergent property that of systems of systems. So these are being the definitions that are being provided by the ISO or IEEE. Then next, systems of systems engineering. So what we'll see in Ian Somerville is software engineering, because we are from computer science background, so we have to see what the computer science background relies to do with software and other mechanical or electrical system. So systems of systems are actually systems, means systems of systems are actually systems. But the thing is that in this kind of system, there are two or more multiple constituent systems are there that works independently and managed and governed independently. Means constituent systems are managed and developed independently and governed independently. So these constituent systems are of multiple, means two constituent system, three constituent system, four constituent system. They all come together and they provide some combined property or combined emergent behavior, and that is system, and that we can call it as systems of system. Then there was a fundamental concept of reductionism that we had studied in very first unit, in the first part. So in the reductionism is a kind of engineering that, and method we can say, that actually breaks down different parts of the different components of the system. And because these components have their own complexity, so similarly you can inherit for the systems of systems. So various large systems of system, means large systems of system could be broken down or reduced down into simpler systems, one or two or three systems. So these actually have the inherent complexity properties. Thus, you have the application of reductionism over here as well in systems of systems engineering. Then, reductionism also assumes that there are some clear boundaries and some rational decision making as well as well defined problems. So, none of these are true in the case of systems of systems, as I had just said in previous slides, that there are very difficult to design some clear boundaries in case of systems of systems, because there are various systems that are working together. Then, and each system have their own defined boundaries, but the different systems are being integrated, so you can't have a clear set of boundary. Then there are various decisions that this system 1 wants to make but system 2 don't want to make, and system 3 denies it. So there are various decision making issues are also there, and some problems that are being well defined in case of reductionism or system, but it is not true in case of systems of systems. Means systems of systems might not have some well defined problem, might not have some rational decision making problem, might not have some system boundaries. Thereafter, some governance and management policies must be designed in parallel for all these type of systems and systems. As in the case of systems as well, we designed some governance and management policies like risk management, like logistics management. So similar governance and management policies are required in systems of systems as well, and they keep on developed with the integration of various systems to create systems of systems. Then we'll see what are the influences and what are the complexities that are being required for managing these systems of systems. So there are basically three types of complexities that are required to be managed in the systems of system. First is technical complexity. So there might be some component failure, so you need a technician to correct that component to make it work. Then there might be managerial complexity, that human resources are there, some selling problems are there, some finance problems are there. You need some managerial complexity and management for the systems of system. Then some governance complexity, means administrator have limited funds to keep on working with the system for these systems of systems. Then governance have some legal issues. So these are the set of complexities. Then key stages. What are the key stages for the SOS development process? Means systems of system development process. These are being similar to the that system key stages for development process that we had seen. So SOS development process have conceptual design phase, like just we had seen earlier. System selection. So this is different. What is system selection? Means there are five systems and we need to integrate three out of them. So what are the objectives that we have and how we want to integrate those three out of five? So this is what system selection, and it depends on very technical things and very managerial things. So the complexity increases when you are dealing with systems of systems. Then architectural design. So there are various systems that are working together, and these systems themselves have some architecture. So how the individual architecture of system one could be connected with individual architecture of system 2, and both these things can be connected with the individual architecture of system 3. So this is what is architectural design complexity issues that you have to face and do while doing the system development process. Then interface development. So we had talked about that architecture of system 1, architecture of system 2, architecture of system 3. So they have their own interfaces, that input of one system could be output of some other. So the output produced by system 1 could be taken as input of system 2, and output produced by system 2 would be taken as input of system 3. So that would be done with the help of interface development. So the interface development is a very important part in case of the system development. Thereafter, integration and development. So the input of system 1 should be properly taken by the input of out input. So output of system 1 should be properly taken by the input of system 2, and output of system should be properly taken by the input of system 3. So that integration testings are required and proper development should be required. Then the SoSE development processes. So basically the systems knowledge and how the systems are being developed or done, and the system had been, how to identify the requirement information. All these things are need to be done at the and done for the conceptual designing phase. Means you need some diagrams and some brainstorming, you need some elicitation techniques for doing all this knowledge and designing, conceptual designing part. Then what are the selections of the systems that you need to do? Then you select some of the systems that are very good in nature. Then you do the architectural design with all the conceptual design and system selection. Thereafter, all these things require some managerial and governance policies in the initial phase itself. So all these governance and management policies are being set out. Thereafter, you develop what interface. So interface development takes place. Then you do the, as a systems of system engineer, you do the integration and development of those interface and systems. So we'll see these steps in detail in this slide. That conceptual design is some activity that of creating some high level vision, means some abstract view of the system was being created. Then defining some of the requirement that identify the all over constraints. So you need to have various type of information that are being developed, managed, and understanding would be developed. So thereafter you have to think for the system selection. And after managing all these constraints and essential requirement and behavior of designing part in the conceptual design, after that you have to do what? Selection, system selection. Then where the in the system selection you have to choose one or two or three systems out of set of systems. So you have given some set of systems and you have to do some inclusion of the some systems in the system of system. So basically there are various issues that been done for the take place for selection. So like political issues are there, some governance policies are there, management policies are there. So these are the key important factors. So politics, governance and management would actually influence. These are the factors that influence which set of systems should need to be selected for the construction of systems. So that's the part that you have to do. Then in the architectural design. So architectural design is basically some overall architecture. Means there, as we had already discussed, that system one output would go to the system two input. So you need to combine the architecture system one with the architecture system two. That's the architectural design. Then interface development. So basically the interface of input and output that just we had discussed, you need to develop the system interface that actually constitute the system interoperability. Means interoperability means input and output, and they could be interoperable, means operations of system 1 and system 2 would be coordinated, that is called interoperable. So you have to develop and design proper interface that of that constituent system. Then integration and development, that is making of different system involved in the SOS work together and interoperable through some development interface. So you have to develop some different kind of system that actually involves various SOS and that works together and achieve some interoperable behavior through some proper development of interface. So the integration and development is the key part on the whole systems of systems engineering. Then these are the examples. So this is just, it will illustrate and clear you what is system of system development and processes. So systems development means putting various systems into place and organized and concerned and making some operations. So various systems are being developed. System 1 is developed, system 2 is developed, system 3 has been developed, and these three put on the same place, and you need to integrate. So you need to develop what service interface, some interfaces are being developed, and then these interfaces are being united together. So united service interface, and then you make the that principal system, means systems of system that you are desiring, and you make this whole thing operationable. So next we'll see system utilities. We'll basically see the reliability, availability, maintainability, and changeability. So I hope